This LOS is calculate and interpret the sources of return from investing in a fixed rate bond. Okay, before we jump into this LOS, it's a new reading, so we'll do a bit of an introduction. The starting point for this analysis is the yield to maturity, or internal rate of return on future cash flows, which was introduced in the fixed income valuation reading. Okay, when we're looking at yields, we're solving for IOI. The return on a fixed rate bond is affected by many factors, the most important of which is the receipt of the interest and principal payments in the full amount on the scheduled dates. Assuming no default, the return is also affected by changes in interest rates that affect coupon reinvestment and the price of the bond if it is sold before it matures. Measures of the bond price change can be derived from the mathematical relationship used to calculate the price of the bond. The first of these measures, duration, estimates the change in the price for a given change in interest rates. The second measure, convexity, improves on the duration estimate by taking into the account that the relationship between price and yield to maturity of a fixed rate bond is not linear, it's a curve. Sources of return. An investor in a fixed rate bond has three sources of return. 1. Receipt of the promised coupon and principal payments on the scheduled dates. 2. Reinvestment of coupon payments. And 3. Potential capital gains and losses on the sale of the bond prior to maturity. Of course, if we hold to maturity, we do not suffer any capital gains and losses because our par value is returned back to us. Okay? So when a bond is purchased at a premium or a discount, it adds another aspect to the rate of return. Recall from the reading on fixed income valuation and also the reading in accounting, you may recall, we went through this very well, that a discount bond offers the investor a deficient coupon rate or one below the market discount rate. The amortization of the discount in each period brings the return in line with the market discount rate as the bond's carrying value is pulled to par. For a premium bond, the coupon rate exceeds the market discount rate, and the amortization of the premium adjusts the return to match the market discount rate. Through amortization, the bond's carrying value reaches par at maturity. Again, we looked at in considerable detail in not only the accounting, but also the previous reading in LOS for fixed income. Should be nothing new there. So continuing with sources of return, we're just going to do some important bullet points here. Number 1, the total return is the future value of reinvested coupon interest payments and the sale price or redemption of principal if the bond is held to maturity. The horizon yield, or holding period rate of return, is the internal rate of return between the total return and the purchase price of the bond. Coupon reinvestment risk increases with higher coupon rate and longer reinvestment time period. That makes sense, fairly common sense. Capital gains and losses are measured from the carrying value of the bond and not from the purchase price. That's an important point. The carrying value includes the amortization of the discount or premium if the bond is purchased at a price below or above par value. And we saw that back in the accounting when a bond is redeemed before maturity and there was a capital gain or loss. Okay, recall that. So and it had to do with the difference between the redemption, if the bond was called, and the carrying value. The carrying value is any point on the constant yield price trajectory. Okay. Interest income on a bond is the return associated with the passage of time. Capital gains and losses are the returns associated with a change in the value of a bond as indicated by a change in the yield to maturity, and that happens when interest rates change. Okay, we'll just bring up the calculator and we'll calculate that yield to maturity. The more we practice, the better, so we might as well. So let's just check this out. We're going to do second PY. Just make sure that the periods per year is 1 because it says here that it's an annual coupon payment. Okay, so it's a 10 years, so we're going to do 10N, and the present value, they're giving us the price, 85.5030, just have to read that carefully, 75, make that a negative on our present value. the payment 8%, so that's going to be 8 payment on 100 par value, which is the future value. So we're going to compute the IY, and sure enough, we have the 10.4%. So the bond's yield to maturity is 10.4%. Nice little review there on the calculator. The more you do it, the better, obviously. So continuing with the sources of the return, the reason why we're going to go through those examples is that I've highlighted 2 bullet points here in red and 1 in green. And what those examples are going to show us is that 2 types of interest rate risk on a fixed rate bond are coupon reinvestment risk and market price risk. These risks offset each other to a certain extent. So just understand what's happening. If interest rates go up, the price of the bond is going to go down. So I get to reinvest my interest at higher levels, but the price of the bond has gone down. Okay, so if I sell it before maturity, I'm having a capital loss. So that's what they're saying about the 2 types of interest rate, reinvestment risk and market price risk. They offset each other, but to a certain extent. So an investor gains from higher rates on reinvested coupons, but loses if the bond is sold at a capital loss because the price is below the constant yield price trajectory. An investor loses from lower rates on reinvested coupon, but gains if the bond is sold at a capital gain because the price is above the constant yield price trajectory. So I don't think that's too difficult concept to understand. You know that if interest rates go down, prices go up. But if interest rates gone down, I need to reinvest my coupon at a lower rate, but the price has gone up, so they're offsetting. If interest rates go up, the price is going to go down. I'm reinvesting my coupons at a higher rate, but I've got a potential capital loss if I need to sell. Okay, so that's the 2 types of interest rate risk. Fairly easy to understand at this point still. So market price risk dominates coupon reinvestment risk when the investor has a short-term horizon relative to the time to maturity on the bond. So that's a key point that's put in. That's what comes out of the examples that we're going to see. Key point in bold in red here. And coupon reinvestment risk dominates market price risk when the investor has a long-term horizon relative to the time to maturity, for instance, a buy and hold investor. Okay, so that's what's going to come out of these examples. Don't be worried about the next few slides. There's quite a bit of math and calculations, but it's just putting you through to prove it to you that about the interest rate risk. And the main point that comes out of it is these 2 important bullet points about market price risk dominating coupon reinvestment risk when you have a short-term horizon, and coupon reinvestment risk dominating market price risk when you've got a long-term horizon. That's the key point. As I've said, I've kept these examples in my slides. They are in the text, but the bottom line is we really need to just understand those rules. And again, I did it as sometimes a little bit of practice on the calculator. Okay, so in the first example, a buy and hold investor purchases a 10-year 8% annual coupon bond at 85.503075 and holds it to maturity. So in addition to collecting the coupon interest and the principal, the investor has the opportunity to reinvest the cash flows at 10.4% because that's the yield to maturity. That's the market interest rate that we're using to calculate the price of the bond. Okay, so what's happening here, I'm just going to show you, is that we set the PY to 1, the mode is the end, N is 10, IY is 10.4, present value is 0, payment is 8. So this is just calculating the future value of the coupon payments. Okay, so that's the value of the coupon payments. And then over here what we're doing is we're doing negative present value, that's the price of the bond, PY equals 1, mode is end, and N equals 10, payment equals 0, but the future value is the interest payments, and if we compute the IY, we're getting the 10.4%, of course. Okay, so as I said, this is the one that we checked. PY is 1, mode N equals 10, present value negative 85.50375, payment 8, future value equals 100, so the IY is 10.4%. Okay, and so we're assuming that the coupon payments are being reinvested at the yield to the maturity. Okay, so the amount in excess of the coupons 49 equals 49.970678, which, because look folks, we're going to have 8 coupon payments times 10, $8 coupon payments times 10 years, that's 80, but we're calculating the future value here, the 129 0.97068 minus 80 is the interest on interest gain from compounding, interest on interest. So the investor's total return is 229.970678, because here you get the interest payments back plus the principal, okay? So you can see that in this example, we're reinvesting the coupons. Again, don't worry about that last slide too much. It's just showing that the yield to maturity is assuming that the interest, the coupons are being reinvested at the same rate, okay, to get to that yield to maturity. Anyhow, let's do a practice question to help our understanding. An investor purchases a 5% coupon bond maturing in 3 years for 102.8, providing a yield to maturity of 4%. At what rate must the coupon payments be reinvested to generate the 4%? A, 0%, B, 4%, or C, 5%? Now, I think you should find that question to be fairly easy, and that's why I did keep the examples in, because it's just so important that you've got such a solid foundation on the bonds and calculating the yield to maturity and some of the assumptions. So the correct answer is B. B is correct since the yield to maturity measure assumes that the coupon payments can be reinvested at an interest rate equal to the yield maturity. In this case, it's 4%. And that's the exact question that's being derived from example 1. So now we're moving on to example 2 from the text. An investor purchased a 10-year 8% annual coupon payment bond at 85.503075 per 100 of par value. But in this case, you're going to hold it for 10 years. So that's important. I put that in bold. In addition to collecting the coupon interest and the principal, the investor has the opportunity to reinvest the cash flows at 10.4%. Okay, so this is what the text is taking you through. And again, it's just to prove these points about how these calculations are made. It's really theoretical, okay? But as you could see from that last practice question, sometimes questions come out of the theory. So again, we're going to set the PY to 1, the mode to N. N equals 4 in this case. IY equals 10.4. Present value equals 0, payment equals 8. Those are the coupon payments. So now we have the future value of those 4 coupons, okay? The next thing that we're going to calculate here, PY equals 1, mode equals N. N equals the 6 years remaining, okay? IY equals the 10.4. We're assuming that's the interest rate still. Payment equals 8. Future value equals 100. So now we've got a present value. We've got the price of the bond. When it's being sold, you're holding it for 4 years. If you want, we'll just bring up the calculator again just to do a little bit of practice instead of just reading all these numbers. Let's just do second, so we're checking, yeah. So we're going to do 6N. We're going to do 8 payment, and we're going to do 100 on the future value. And we're going to do IY is 10.4 because we know that's the market rate right now. So we're going to compute the present value, and we've got the price 89.6687. Okay, you can see that. So I'm just going to slide the calculator over to this side, and we can see now, and again, this is just showing you know, how the yields are consistent. PY equals 1, mode equals N, and N equals 4. Present value equals negative 85, that's the current price. Payment equals 8. Future value equals 89.6877. If we compute the IY now, we can see we're getting the 10.4%. So what this is doing is that I'm just going to make that a positive, make that the future value, okay, because that's what I'm going to sell the bond at after 4 years. We calculated the price. 8 is the payment, okay. The present value is 85.503075. We'll make that a negative on the present value. And we know that N equals 4 for N. Compute the IY, and we've got our 10.4%. Okay? So what's it saying down here? The interest on interest gain from compounding is 5.34711. Example 2 demonstrates that the realized horizon yield matches the original time to maturity yield to maturity if 1, coupon payments are reinvested at the same interest rate as the original yield to maturity. So that's what we're doing here, okay? We're using the 10.4 and the 10.4. And so when we calculated the IY here, we're seeing that we're getting the same yield to maturity. And 2, the bond is sold at a price on the constant yield price trajectory, which implies that the investor does not have any capital gains or losses when the bond is sold. So this is example 2 done now. So continuous sources of return, what this graph is saying, it's talking about capital gains arise if a bond is sold at a price above its constant yield price trajectory, and capital losses occur if the bond is sold at a price below its constant yield price trajectory. The trajectory is based on the yield to maturity when the bond is purchased. So recall, if a bond is purchased at a discount, in this case, let's say it's at 85, it's going to be pulled to par as it moves closer to maturity, okay? And so in the previous example, we're using the assumption that the the interest was being reinvested at the same rate as the yield to maturity when we originally purchased the bond. So everything was happening on the constant yield price trajectory. So now we're moving on to example 3 here. And in example 3, it's the buy and hold investor purchased the 10-year 8% annual payment bond at 85.503075. That's what we've been using in all the examples. But in this case, after the bond is purchased and before the first coupon is received, interest rates go up to 11.4%. Aha. So we're going to calculate the future value of the reinvested coupons at that higher rate for 10 years. And we get that future value to be 136.30195. Now again, these examples are just going through the theory about what's happening. I'm reinvesting my coupons at a higher rate, so I'm calculating what the IOI is on the bond, okay? So you can see here, let's just run through this. So that's 10N. Interest rates went up, 11.4 is, 11.4 IOI, calculator keystrokes, pay attention to detail. 0 present value because we're talking about the coupons. It's an $8 coupon, so we're going to calculate the future value, the 136.38. That's the future value of the coupon payments being reinvested at an interest rate of 11.4%. So when we move over to this calculation here, what are we doing? PY equals 1, mode equals N, 10 years. We know the price, 85.50375. 0 payment, we're not talking about the coupons because we're adding the future value of the coupons being reinvested to the $100 par, and we're calculating the IOI, okay? So here, if I just do that and I add my 100, then I can make that the future value, okay? Going to be 0 payment. Our present value is the price, 85.503075, and we make that a negative as our present value, okay? And it's for 10 years, 10N, and we're going to compute then the IOI. Oops, sorry. We're going to compute the IOI, and we've got 10.703904. That just showed you sometimes you do make a calculator keystroke error. You don't need to restart, just clear it, and I just did compute IOI if you saw that little mistake that I made because I'm using a pen and a tablet. Sometimes it's a little bit more difficult than using the real calculator. Anyhow, we've got the IOI of 10.7039, and so what this example is showing us that the buy and hold investor benefits obviously from the higher coupon reinvestment rate. The realized horizon yield is 10.7%, 30 basis points higher than the outcome in example 1, when interest rates are unchanged. There is no capital gain or loss because the bond is held to maturity. The carrying value at the maturity date is par value, the same as the redemption amount. So continuing with the sources of return, we could see in example number 3, we're holding the bond to maturity. So only the reinvestment income is affected. So this is fairly logical. The yield to maturity increases if the reinvestment rate increases, and it increases the realized return. So we could see that when we bought the bond, the yield to maturity was 10.4%, but the interest rates went up to 11.4%. So the return to us on our bond was 10.7%, okay? So here's just reinvestment risk is greater than the price risk. There is no price risk because you're holding the bond to maturity in this example. When we get to the later examples, we're going to sell the bond before the maturity. So in this one, yield to maturity increase, reinvestment rate increased, increase the realized return. Obviously, it's the opposite if the rates go down. So here we just have a little bit of algebra. The rate of return equals the coupons plus the par plus the reinvestment income divided by the purchase cost to 1 to the n minus 1 for the people that love algebra. If we just bring up the calculator here, you can see I just copied over from the, so it was on this slide, the previous examples. So you can see our coupons plus our par plus our reinvestment income, that was going to be the 236.38, correct? 38019. So 236.38019. We're going to divide by the purchase cost, which was our 85.503075. And we're going to do y to the x. We're holding it for 10 years. 1 divided by 10 is 0.1. And we're going to do minus 1. And if we want to multiply by 100 to get a nice round number, we get our 10.7039, which is here 10.7039, same as when we use the time value of money functionality on the calculator. So here's the algebra here, just for those of you that love the algebra. So now we're moving on to example 4. And example 4, it's the second investor is going to buy the 10-year 8% annual payment bond at 85.50375. But in this case, you're going to sell it in 4 years. Okay, not going to hold it to maturity. So after the bond is purchased, interest rates go up to 11.4%. The future value of the reinvested coupons, 11.4%, is 37.899724. Now, I won't bring up the calculator in the interest of time because I just want to go through this example. And again, if I was studying, I'm really pressed for time for the exam, I wouldn't go through all these examples. I wanted to make sure that I included them because they are in the text and it is the theory. But again, we're just working through the calculations in the theory to prove to you this point. The red bullet point, which is the most important point, is that market price risk dominates coupon reinvestment risk when the investor has a short-term horizon. So don't get all hung up with all these calculations and the math and what's he doing here. It's just proving, it's just working it out to show you, hey, that's the fact. Okay. Again, if I was really pressed for time studying with a couple of weeks left, I'm going to skip over some of the theory and just focus on the calculations and some of the key bullet points. But nevertheless, if you've got time, it is nice to go through because this creates a very solid foundation with your understanding of the dynamics with regards to the bonds. Okay, so we can see here PY equals 1, mode equals N, N equals 4, and the interest rate has gone up. That's why I've got that in bold. Present value equals 0, payment equals 8. So I've got my future value, my coupon payments that I've received and reinvested for 4 years. Okay, and again, I'm not going to bring up the calculator, just going to speed through. So now what we're looking at on the second column, PY equals 1, mode equals N, N equals 6. What we're calculating here is the price of the bond when I go to sell the bond after 4 years. That's what I'm doing in this column. Okay, so N equals 6 because it's a 10-year bond and I'm selling it after 4 years. IY equals 11.4 hasn't changed. Payment equals 8. That's my coupon payment. And the future value is 100 because that's when the bond matures. And I'm going to get a present value, a price of 85.78041. So what am I doing finally in this last column? You can see PY equals 1, mode equals N, N equals 4. Okay, because I'm going to sell the bond after 4 years. Present value is the price. That hasn't changed. We've been using that the same in every example. Payment equals 0. Why? Because for the future value here, I'm combining the future value of the coupon payments. You can see that little plus sign, I put it there, plus the price when I sell it. That's giving me the 123.68013. Okay, you can see that little arrow. Sometimes that confuses people. And I'm computing the IY, and lo and behold, I'm getting a yield to maturity of 9.66%. Okay. So what has happened is interest rates have gone up, the price of the bond has gone down. Even though I'm reinvesting my coupon at a higher rate, I'm getting a lower yield, and that has just proven this in red here, that market price dominates coupon reinvestment risk when the investor has a short-term horizon relative to the time to maturity on the bond, okay? Because when we bought it, the yield was 10.4%. interest rates went up to 11.4, but I'm going to sell that bond early. I'm only getting a yield to maturity of 9.66%. Okay, so that's it. That's what this examples are for. It's just to prove to you the theory behind that. So if we just read here on the bottom, I know the text is a little bit small, I'll just read it for you. In example number 4, the second investor has a lower realized rate of return compared with the investor in example 2, in which interest rates are unchanged. The future value of reinvested coupon payments goes up because of the higher interest rates, but there is a capital loss. Notice that the capital loss is measured from the bond's carrying value, the point on the constant yield price trajectory, and not from the original purchase price. The bond is now sold at a price below the constant yield price trajectory. The reduction in the realized 4-year horizon yield from 10.4% to 9.67% is a result of the capital loss being greater than the gain from reinvesting coupons at a higher rate, which reduces the investor's total return. Okay, so I don't think that's too difficult. Interest rates went up, price went down. I'm selling the bond before maturity. I had a capital loss, and the price change dominated. The market price risk dominated. Okay, so you could see in that last example, the sale price was affected. So the yield to maturity went up, the sale price is down, and it decreased our return. If the yield to maturity goes down, obviously the sale price is going to go up. It's going to increase our realized return. And as we saw from that example, the price risk was greater than the reinvestment risk. Won't go through it here, but here's the algebra, the rate of return, coupon plus the sale price divided by purchase cost minus 1. Okay, so we're going to move on now. So in example number 5 here, the buy and hold investor purchased the 10-year bond at 85.503075, holds the security until it matures, so not selling it early. After the bond is purchased and before the first coupon is received, interest rates go down to 9.4%. The future value of reinvesting the coupon payments at 9.4% for 10 years is 123.888356. Okay, so I'm not going to bring up the calculator for this. We're just going to whip through it again. It is a bit of the theory, so you can see we calculated the future value of the coupon payments, and we're using that to then calculate the yield to maturity on the bond. So in the second column, PY equals 1, mode equals N equals 10 because we're holding it to maturity. The present value is the price of the bond right now, no payment because we're combining the future value of the coupons with the 100 that we get back. So the future value is 223.88836. And if we compute the IY, we're going to get 10.10448. Okay, so recall that when we purchased the bond, the yield to maturity was 10.4%, but now interest rates have gone down 9.4. I'm still getting a yield of 10.1%. Okay, because I'm holding it to maturity. I'm not selling the bond early. We can know it. We can forecast what's going to be in example 6. It's going to be the same as this. Interest rates go down, but I'm going to sell the bond after 4 years. You see where this is headed? Okay, so in example 6, it's the 10-year 8% annual payment bond bought at 85.503075 and selling it in 4 years, but the interest rates have gone down to 9.4. So again, we've got the 3 columns here. We're going to calculate the future value of the coupons after 4 years at an interest rate of 9.4%. Then we're going to calculate the price of the bond when we're selling it at after 4 years, so there's 6 years remaining, and the interest rate is the 9.4. Again, not going to pull up the calculator. If you still need practice, you can do it on your own. And we're going to get the price of the bond to be 93.7939. We add the future value of the coupons plus the price of the bond when we sell it, and we put it here. We've got N equals 4. That's how long we're going to hold the bond. Present value is the price. Payment equals 0 because we're adding the future value of the coupons with the price that we're going to sell at. And lo and behold, what are we going to get? We're going to get an IOI yield to maturity of 11.16. So remember, when we bought that bond, interest rates were 10.4%. Then interest rates went down to 9.4%, but I'm getting a yield of 11.16. Why? Because when interest rates go down, bond prices go up, and so the market price risk again has dominated the coupon reinvestment risk when you've got a short-term horizon. So the investor in example number 6 has a capital gain. Capital gain is measured from the carrying value, the point on the constant yield price trajectory. That gain offsets the reduction in the future value of reinvested coupons. The total return is higher than in Exhibit 2, and where the interest rate remains at the 10.4%. Interest rates went up, price went up, and we had a nice little gain on our yield to maturity. So this slide has a bit of a summary on the key points with regards to sources of return. The investment horizon is at the heart of understanding interest rate risk and return. There are two offsetting types of interest rate risk that affect the bond investor: coupon reinvestment risk and market price risk. And that's why we went through the examples. Again, if you're pressed for time, I would say skip them. Jump to this slide. We're just proving the theory. The future value of reinvested coupon payments, and in a portfolio, the principal on bonds that mature before the horizon date, increases when interest rates go up and decrease when rates go down, obviously. And the sale price on a bond that matures after the horizon date and thus needs to be sold decreases when interest rates go up and increases when rates go down. Of course, you know that. So just a little summary of some of the key points, help you catch your breath there. Coupon reinvestment risk matters more when the investor has a long-term horizon relative to the time to maturity of the bond. For instance, a buy and hold investor only has coupon reinvestment risk. Of course, the principal is going to mature at par. Market price risk matters more when the investor has a short-term horizon relative to the time to maturity. So, for example, an investor who sells the bond before the first coupon is received has only market price risk, okay? Therefore, two investors holding the same bond or bond portfolios can have different exposures to interest rate risk if they have different investment horizons. So just a quick practice question here, which is a bit of a forecast of things that we're going to look at. The most relevant definition for duration is A, a security's price sensitivity to changes in yield, B, the first derivative of the security's price with respect to yield, or C, the weighted average time until receipt of the present value of cash flows. Okay, we've been looking at the examples of the price sensitivity to changes in yields, so that is talking about duration. The most relevant definition of duration is a security's price sensitivity to changes in yield. This is the most relevant definition because users of duration are interested in a security's price sensitivity to changes in yield. And one last practice question to finish this LOS. The duration of a fixed income portfolio is best interpreted as A, first derivative of the price function for the bonds in the portfolio, B, percentage change in the portfolio's value if interest rates change by 100 basis points, or C, weighted average number of years to receive present value of the portfolio's cash flows. And the correct answer is B. The duration of a fixed income portfolio is best interpreted as the percentage change in the portfolio's value if interest rates change by 100 basis points. Users of this interest rate risk measure are interested in what it tells them about the price sensitivity of a bond or portfolio to changes in interest rates. Therefore, B is correct. Okay, I just want to finish this LOS by looking at the three practice problems at the back of the chapter that are relevant to this LOS. Again, we went through a lot of calculations there and the math, but that was really just proving the points with regards to the dynamics on yield to maturity, etc. Okay, so if we look at these three questions, just look at them very quickly. Number one, a buy and hold investor purchases a fixed rate bond at a discount, holds the maturity security until it matures. Which of the following sources of return is least likely, so we're looking to the false, to contribute to the investor's total return over the investment horizon, assuming all payments are made as scheduled? So is it A, capital gain, B, principal payment, or C, reinvestment of the coupon payments? Well, reinvestment of the coupon payments is relevant. So is the principal payment. We got to get the money back. So it's A, capital gains. Okay, that's the least likely that's going to contribute to the investor's total return. Number two, which of the following sources of return is most likely exposed to interest rate risk for an investor of a fixed rate bond who holds the bond until maturity? Is it capital gain or loss? No, I'm holding it to maturity. I don't have capital gain or loss. Redemption of principal? No. It says you're going to hold it to maturity, assuming you get your principal back. It's the reinvestment of the coupon payments. That's the interest rate that you're exposed to. Finally, number three, an investor purchases a bond at a price above par value. Maybe I'll just scroll that up so you can see it a little bit better. 2 years later, the investor sells the bond. So that's why I did go through the examples, the theory. The resulting capital gain or loss is measured by comparing the price at which the bond is sold to what? The carrying value, the original purchase price, or the original purchase price value plus the amortized amount of the premium? Well, we know we're always comparing against the carrying value, okay? So I just encourage you to go to the back of the text and always work through the practice problems. And that's the last for this LOS. It's been a bit of a long one. Thank you.